Today we will start with measurement of current and potential difference. The device which is used to measure the current, the device which is used to measure the current is known as a meter. It has low resistance and is always connected in series in a given circuit. While the device which is used to measure the potential difference is known as voltmeter. It has a high resistance and is always connected in parallel in a given circuit. Now we will start with Ohm's law. This is the most important law in the electricity. According to Ohm's law, the potential difference across the ends of a conductor is directly proportional to the current flowing through it. But there are some conditions which must be fulfilled for this. That is, the temperature and the physical conditions should remain constant. Means, according to Ohm's law, V is directly proportional to I, where V is potential difference and I is current. We can also write V is equal to IR, where R is constant, which is termed as resistance. Now, resistance is defined as the opposition offered by the conductor in the path of current. Means resistance always opposes the current flowing in the conductor. Its SI unit is ohm, which is denoted by the sign of omega. From equation 1, we can say that R is equal to V by I. In the given circuit, it is represented as in a given circuit, we can connect resistance either in parallel connection or in series combination. So, first we will study about the series combination of resistance in the given circuit. Combination of resistance in series. This is a cell having the voltage V, current I, this is resistance R1 and this is resistance R2. In this figure, we have two resistors R1 and R2 which are connected in series. The current I is flowing in this circuit. In series combination, the current in the circuit always remains same at all the points. Let R be the resistance across the potential difference V. So V1 is potential difference across the resistance R1 and V2 across the resistance R2. By Ohm's law, V1 is equal to I R1 and V2 is equal to I R2. Total V is equal to V1 plus V2. On substituting the values of V1 and V2, we get IR1 plus IR2. On taking I common remains R1 plus R2. V by I is equal to R1 plus R2, and according to Ohm's law, V by I is equal to R. Now, combination of resistance in parallel. This is a circuit diagram which shows the combination of resistance in parallel. The resistors connected in this circuit are said to be connected in parallel. The potential difference across each parallel branch remains the same. The sum of the current will be different through each branch. Again, we will use Ohm's law. So, by Ohm's law, I1 is equal to V R1 and I2 is equal to V R2, where V is potential difference, R1 and R2 are two resistors which are connected in parallel. I is the total current in the circuit. Total current I is equal to I1 plus I2 on substituting the values of I1 and I2 as V by R1 plus V by R2, we get V is taken as common, so 1 by R1 plus 1 by R2, 1 by R1 plus 1 by R2, which is equal to 1 by R by using Ohm's law, where R is the total equivalent resistance in the circuit. So, when the resistance are connected in series, they are simply added to give the equivalent resistance in the circuit. But if the resistance are connected parallel in the given circuit, then reciprocal of the resistance is taken and they are summed up to give the equivalent resistance in the circuit. Now, we can also calculate the resistance mathematically by using length area of the wire given to us. It has been found that resistance R of a conductor is directly proportional to the length of the conductor. We have considered that length of the conductor is A, but R resistance of a conductor is inversely proportional to the area of the cross section of the conductor. We have taken area of cross section as A. On combining above two equations, we get R is proportional to L by A. It implies R is equal to rho L by A, where rho is constant known as resistivity, where rho is constant and termed as resistivity. This rho is also known as specific resistance. Unit is ohm meter. The reciprocal of this resistivity is termed as conductivity. It is represented by sigma. So we can say that sigma is equal to 1 by rho. Unit of sigma or conductivity is 1 by ohm meter, which can also be written as mho per meter, because 1 by ohm is equal to mho. Electrical energy. As we have initially studied that energy is the ability to do work, but the electrical energy is the work done is the product of charge and potential difference. Means electrical energy is expressed by the amount of electric work. While studying electric potential, we have studied that potential is equal to work done per unit charge. It implies electric work done is equal to potential difference and product of potential difference and charge Q. Q can be expressed in the terms of current as current into time. On substituting this value of charge in above equation, we get V, that is potential difference, into I, that is current, into T, that is time. This equation represents the amount of electric work done, which is equal to electrical energy. But if we want to express this electrical work done in terms of I and resistance R, we can express it by using Ohm's law. By using Ohm's law, V is equal to IR. Substitute this value of V in above equation, we get I square RT. It represents again the amount of electric work done, which represents the electric energy. SI unit of electric energy is joule, and its commercial unit is kilowatt hour. The commercial unit of energy and the SI unit of energy are related by the equation, which states that 1 kilowatt hour 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Now we will study about electric power. Power is defined as the amount of work done per unit time, or as the rate of doing work. So, electric power is defined as the rate of doing electric work. It is denoted by P. P is equal to electric work done per unit time. Its SI unit is watt.